So I'm going to speak about Zadeh dual interpretation of fuzzy logic. And the idea for this talk came from time that I spent writing a book that is going to be published in April that is called Soft Computing Evaluation Logic. So I was forced to think about logic. And we've heard today many times the word logic and fuzzy logic. Okay, and since I'm an electronic engineer, when you say logic, I always think these are chips that have and, or, and half others inside them, similar things. That's what electronic engineers think that it is logic. And of course, in the area of fuzzy systems, when you say fuzzy logic, there is a problem that is visible here. One of awards that was given to Lotfi Zadeh was in 2013, which was practically a few days ago, at least from my perspective. And then he addressed the BIS community on January 25th. And he said, BBVA award has rekindled discussions and debates regarding what fuzzy logic is and what it has to offer. So this looks as a very strange beginning of an address to community, simply because there were almost 50 years of successes of fuzzy systems, and then still there is no proper definition for fuzzy logic. Of course, if you speak about France, you can use terms in a way that is understandable to everybody. However, logic is a tricky area because it exists 24 centuries. Okay, so we have to be careful when using the word logic, and I want to discuss a little bit pros and cons in this area. So here is the whole address that Zadeh sent to all people here, I guess. So you've read this, but let us just say a few things. This in red. He said fuzzy logic has two different meanings. Fuzzy logic in a narrow sense and fuzzy logic in a wide sense. So that's what he explicitly said. And then, narrow sense fuzzy logic is a logical system which is a generalization of multi-valued logic. Multi-valued logic is logic. There is no doubt about that. On the other hand, he said, wide sense fuzzy logic, call it FL, is much more than a logical system. Informally, FL is a precise system of reasoning and computation in which the objects of reasoning have unsharp boundaries, of course. The centerpiece of fuzzy logic is the concept of fuzzy set. And then he terminated by saying, in fact, most applications of fuzzy logic involve no logic in its traditional sense. So this is a perfect way to make a controversy, which is still here. And let us discuss a little bit this controversy and to see various aspects that we have related to it. So, Zadeh's interpretation of fuzzy logic was dual, narrow sense and wide sense. So, fuzzy logic in wide sense includes almost all intellectual descendants of the concept of fuzzy set. So, everything that was derived from this big root called fuzzy set is called fuzzy logic. And all applications based on these concepts are also considered fuzzy logic. On the other hand, fuzzy logic in the narrow sense is a generalization of multi-valued logic. So it is logic itself. So using fuzzy logic in wide and in narrow sense interchangeably creates debates and controversies, and they are still present. So how to classify sentences and logics? Well, we have here one figure that tries to do that. Linguistic sentences that are expressions in a natural language can be truth bearers or not true bearers. Like not true bearers are questions, exclamation, request, command, suggestion, and similar things. On the other hand, truth bearers are called statements or propositions. They can be either crisp or graded, and here is where the fuzziness come into play, as well as here. Even requests can be, of course, fuzzy. Give me a little bit of water. Okay, so this is obviously not precise. So fuzzy logic in the wide sense affects all this what is related to human communication and reasoning. But in particular, I was interested in truth bearers. That means in statements or propositions that are claiming that something has a specific value. So these graded statements can have a value statement or not value statement. And so we have that fuzzy logic in wide sense has as a subset fuzzy logic in narrow sense. And then from this beginning and from classical logic, which is logic from Aristoteles to Augustus de Morgan and George Boole, we can practically create a generalization of Boolean logic, which I called graded evaluation logic or graded logic or GL. So how to put all this together and what concept we have to take into account when we speak about logic. Now, here are several concepts like truth, importance, value, suitability, preference, satisfaction, comes in degrees, fuzzy set membership, endness, orness, penalty, reward. All these concepts are graded concepts based on continuous transition from 0 to 1. If we ask what is the degree of satisfaction of specific requirement, can go from 0, no satisfaction at all, to perfect satisfaction at the top. And this is something that is basic component of human reasoning. Therefore, if we speak about logic, we should practically take into account human reasoning and investigate human reasoning. So in soft computing, what we have as a concept that is different from, say, mathematical concept of building logics as formal systems. First of all, graded truth has semantic identity. That is forgotten in mathematics in the sense that truth comes from statement, and statement has a meaning. And this meaning means something for stakeholder or decision maker. So in the area of aggregation, we don't aggregate real numbers. We aggregate concepts that have semantic identity, that have meaning, and we put them together. The same is if you speak about fuzzy set membership. This has unit that is explained in the sense what this fuzzy set means. That's the first thing. Second thing, people speak about simultaneity, which is conjunction. Conjunction that occurs in human mind can be soft, hard, or hyperconjunction. Soft is conjunction that does not support annihilators. Hard is supporting annihilators. And hyperconjunction is something like T-norm or something that is stronger than T-norm. Therefore, everything that happens in unit hypercube. The same is with graded disjunction. When people think about conjunction, for example, you are buying a house, and then you come to two values that you want to merge together. One is the quality of the house, and the other is quality of location. Now you want to say, what is the level of satisfaction with this house? Well, you want at the same time good location and good quality. Now I'm going to ask you, are you going to accept a house that is perfect, made for Donald Trump, but it is in Sacramento, and you work here in Berkeley, have to travel each day 3 hours or who knows how much. So you are going to, no, I don't want to accept this castle in Sacramento, which means you have an annihilator. That's how you say that in mathematics, okay? On the other hand, you have cases where you evaluate things where annihilators are not necessary. Okay, so that is just visible in human reasoning. There is no doubt about that. There are examples that show that. Then, in human reasoning, you have plenty of use of partial absorption, which is a function that combines mandatory inputs and optional inputs. So if mandatory inputs is missing, you reject everything. For example, you are again buying a house and you want to have a garage in the home so that you can leave the car there. But it is a good thing to have also parking in front of house on the street. So for some buyers, it is mandatory to have garage in the house. And it is optional and desirable, but not mandatory, to have parking in front of house. If I ask you how good is parking around your home, you are aggregating something that is mandatory and something that is optional and saying I'm satisfied 85%, more or less completely. That's how human reason with that. Graded disjunctive partial absorption is the same kind of animal except that it is disjunctive. It is combining sufficient and optional inputs. One thing that I am extremely sensitive to is importance. Why? Because mathematicians start by saying, here is the operator and it is commutative. There is no commutativity in human reasoning at all. The first what you have to kill is commutativity, and then you can build mathematics. Because in human reasoning, everything has importance. No two things are equally important. For example, for somebody, it is more important to have good quality of house than the good quality of location. For some other people, they say location, location, location. That's what all realtors say. So you want to have perfect location, and the quality of house is mandatory, but not that important. So there is never in human reasoning equal importance of everything. Everything has different importance. Now, you can ask the question, hey, during 24 centuries, from Aristotle to George Boole, nobody mentioned that importance is part of human logic. All things, all truths are absolutely equally important, from the first to the last. You have conjunction, minimum between x and y. Wait a second. Why x is equally important as y? Well, because we define it that way, and nobody thinks, is this a model of human reasoning? It is not. Human reasoning is based on graded importance, which is semantic aspect. Semantic aspect because what people say has meaning, and this meaning can have some degree of truth that has semantic identity. It is not anonymous real number. I call that anonymous real number. That means real number without meaning. We start with real numbers and then we do acrobatics, which is perfectly legitimate in mathematics. It is not legitimate in decision engineering. It doesn't work there. So, aggregation based on several properties of human reasoning is something that should give us a kind of logic that is closer to humans than what is done in mathematics. And indeed, wide sense fuzzy logic is going far beyond logic. For example, you have image processing, computer vision, encryption, optimization, fuzzy control systems, pattern recognition, etc., etc. All this has nothing to do with logic. it is something that is usually called fuzzy system. And of course, it is based on the concept of fuzzy sets and belongs to fuzziness 100%, but not to logic. So the question is, should we really call that logic or not? Well, there are various forms of logic that should not be ignored. First of all, there is Boolean logic, binary Boolean logic, true, false, and then you have conjunction, disjunction, implication, whatever you want, 16 functions of 2 variables. Then you have fuzzy logic in narrow sense, defined by Zadeh, and fuzzy logic in wide sense, which is also specified by Zadeh in the way that we said. So we can say that this Boolean logic is somehow a subset of graded logic, which is subset of fuzzy logic narrow sense, which is subset of fuzzy logic wide sense. So you have these more and more generalizations. In the sense of Boolean logic is logic that works in vertices of unit hypercube. And graded logic works inside the whole hypercube. And of course, fuzzy logic in narrow sense is the same idea. So let us try to answer what is fuzzy logic. Zadeh prefer to say fuzzy logic is fuzzy logic in wide sense. That means all intellectual descendants of the concept of fuzzy set are called logic. Okay. Alternative interpretation could be that you simply say fuzzy logic. Let us be a little more fuzzy and say these are fuzzy systems. Let us call FS. And then in that case, fuzzy logic could be fuzzy logic in narrow sense, which is subset of fuzzy systems. That would be one of possibilities, with ultimate respect for word of Lotfi Zadeh. There is no doubt about that. We could try to promote the idea that we have fuzzy systems, and there is fuzzy logic, which is indeed only logic. So if we try to go in that direction, we can say logic does exist 24 centuries, okay? And it is the major respectable part of philosophy for everybody except us electrical engineers and mathematicians who have different interpretation of these words. So if you go to English language, which is not my native language, you always take a dictionary and say what Webster is saying. Webster is saying logic is the science that investigates the principles governing correct or reliable inference. Inference happens here, not in chips. Okay, that's what Webster is saying. We are not going to kill him. Then there is little Webster or big Webster called Wikipedia. They say logic, systematic study of the form of valid inference. This again inference. Okay, so that's what English language thinks about logic. Okay, I'm not guilty for that. Then we look what happens in these 24 centuries. Let us start with Aristoteles. Aristoteles was, of course, investigating logic and syllogism, and he was speaking about truth and falsity, and it was binary. That means these two. Augustus de Morgan was also binary, but if you read his books, you will find unbelievable definitions of fuzziness inside. That is written, I can show you that, and I have this in my book. He was in 1806 to 71. At the same time, George Boole was also creating concepts that were binary. And this all changed with Jan Lukasiewicz. Lukasiewicz first introduced the third one. Between 0 and 1, there was something he said. Actually, he said -1, +1, and 0 in the middle. Then after said why 3? We can have n of them. Okay, that was n-valued logic. And after that, Lukasiewicz said, okay, let us have an infinite number of grades and made, let us say, continuous logic. That's what embraced also Lotfi Zadeh. So we were going from 2 to infinity. And all these are contributions to logic, to modeling of human reasoning. Therefore, if we want to say what is logic, logic is, of course, key component of human reasoning. Therefore, logic should be based on observable properties of human reasoning. And it should serve for quantitative modeling of human reasoning. So I'm going to observe people that are making decisions. They are reasoning in a specific way. And I'm going to try to make mathematical models of what I can observe. Of course, I don't have voltmeter to measure that objectively, but I can see how people reason, and I can get justification why people reason in that way. So there is no doubt that when you buy a house, you really want to have good location and good quality of house at the same time. So you can say here is a conjunction, which is model of simultaneity. And all human reasoning is based on combination of simultaneity and substitutability and negation in various degrees. And we mix that somehow in our head and create logic reasoning based on that. Now, books that were promoting human-centric approach to logic. When I say anthropocentric or human-centric approach to logic, that means founding fathers, Augustus de Morgan, wrote a book in, both books were written in 47. So the calculus of inference. So they were badly trying to model human reasoning. That was what they wanted, that was explicitly written. The same is with George Boole. He said investigation of the laws of thought. So how we think, what are laws that are inside? That's what was logic for De Morgan and George Boole. While De Morgan had also explanation of things that are soft in the sense that are moving from truth to false, but he was not brave enough to formalize that at all. Now, going to investigate degree of truth. Let me again say, degree of truth is not an anonymous real number. It is something that has semantic identity and interpretation. So, truth is related to carefully formulated and precisely defined statements. There is no truth that you can measure. Truth is something that comes in human reasoning as a percept of something that is partially true. Is this glass of water full or not full? If you say it is full, that means it is not 100% full. It is partially full. And you can say what is the degree of that. Statements are specified by stakeholders, by people who have, humans who have goals and interests. Then, each statement has a role of meaning based on stakeholders' goals and interests, and degrees of truth have also semantic identity. They have meaning to people. Soft computing logic must be graded and combine formal logic and semantic components. There must be importance in logic. Logic without importance is 23 centuries, but not 24. We need that as a part of formal theory. It has to be there, because people do have that. Degree of fuzzy membership. In most cases, degree of fuzzy or degree of truth can be interpreted as the degree of fuzzy membership. And this is very important and, of course, shows big overlap between logic and fuzzy membership. So if you say my job completely satisfies all my requirements, that is, say, 80% true, which is also a and degree of membership of job in the set of fuzzy jobs. So when we look some rather well-known publications, fuzzy systems, fuzzy sets and systems. There is no transaction of fuzzy logic. They believe in systems. So let us ask Hamlet what Hamlet would say about FL. He will say, to FL or not to FL? That's the question. So either we are going to say we have fuzzy logic with fuzzy logic in wide sense, or fuzzy systems that have fuzzy logic as a subset. So that's what Hamlet is saying. What will say Julia in Romeo and Juliet? What's in a name? Julia says, what's in a name? That which we call a rose by any other name would smell as sweet. So you can use it fuzzy, you call it fuzzy logic and not being logic, or ask to be logic in another way. I would say that what is in a name? Plenty. Plenty. Proper name eliminates controversies. So my conclusion of this respectable presentation of logic and Zadeh's legacy, I would say that controversial dual interpretation of fuzzy logic does not contribute to Zadeh's legacy. Try to think what's going to happen 300 years from today when things are going to have same distance like today we have distance from Augustus de Morgan or Aristoteles. Things will change. Keeping fuzzy logic strictly within the realm of logic contributes to logic and eliminates controversies that affect Zadeh's legacy. Fuzzy systems are an appropriate general term that can include all descendants of the concept of fuzzy set, including fuzzy logic. So that would be my conclusion. Thank you very much.
Thank you. Were you using dual in the sense of duality, for example, or you mean double? What do you mean when you say dual?
In this sense, duality is not interpreted as something that is complementary, but as something that is subset structured. That means that you can call it fuzzy logic, but then you say it is in narrow sense. And then you say fuzzy logic now, it is in wide sense. Now, if you think that it is in wide sense, and I think that it is in narrow sense, when we start discussing, there is going to be interference and we are going to have misunderstanding and debate and controversy. If we say fuzzy logic is logic, and fuzzy systems are all systems that are based on fuzziness, imprecision, uncertainty, concept of fuzzy set. Everything is perfectly clear. No any controversy, no any debate, everything would be clean. Well, that's what I think about that.
You mentioned fuzzy encryption. But I think encryption is not fuzzy because, look at the encryption used in beacon. They use a public key and a private key.
Yeah.
All these are not fuzzy.
There are some new approaches to that. What I wanted to do is how to answer what is fuzzy logic. You can say, why don't we take a book that is entitled Fuzzy Logic and see what are chapters inside. And actually, this is the list of chapters from a book that has fuzzy logic. So I want simply to say that fuzzy systems are a great idea. Plenty of engineering is based on it. And all journals that we appreciate so much, Transaction of Fuzzy Systems or Fuzzy Sets and Systems, speak about not fuzzy logic, but fuzzy systems, because this is a wider concept. I wouldn't change the meaning of word logic, neither for chips that have AND gate inside, nor for fuzzy concepts that are called logic because they have something to do with human reasoning. But logic is more narrow area, and therefore let us keep it there. Fernando.
I'm curious, how old before do you How would explain to a decision maker in decision science when you say decision X equal to 3, it's something that you call anonymous real number. How you would add semantics to this anonymous fuzzy number to communicate with the decision maker?
Okay. Let me answer in this way. When you say decision maker, you practically have 3 components inside. In all evaluation problems, you have first the stakeholder. This is, for example, military that is buying a fighting jet. Second is domain expert. If you want to create attribute tree with attributes that are important, in that decision-making committee, there must be a pilot who knows what is important and what attributes you have to take. The third component is evaluator, the decision engineer who knows how to make models of reasoning. And now these 3 people together, sit together, and we call them decision maker. So one is responsible for using the object of evaluation, the other is responsible of modeling evaluation process, and the third one is telling you what is important, what is not when I go with this fighter jet. So these 3 components are put together, and then we define an attribute tree of all components that have to be taken into account. Okay. And then after that, for example, in trivial case of finding the quality of location for a family, you have that you find what is the distance from job for parents, what is distance from school or nursery for children, and then you evaluate all these things separately, and then when you have degrees of truth, how good is one thing and the other, then you aggregate them in your head. Then comes the theory of aggregation together, okay? However, in this case, sometimes you have that the stakeholder is at the same time domain expert, because nobody can be better expert for location of your home from the standpoint of distance from your job than yourself, okay? And also, in some cases, we don't need domain experts because everybody is domain experts when you are buying oranges or apples. And I say in English, then don't compare apples and oranges. What kind of nonsense is that? Have you ever been in a grocery store? You have apples and oranges and you compare them, of course they do. And you make attributes like color, freshness, price, everything. Aggregate it separately, put them in your head and say oranges are better than apples. I'm going to buy 4 kilos and come home with them. So this is what people do. If you observe them, you see them doing that every day. This is what human perceptions are doing, and aggregation on percepts in order to make decisions. So if you are deciding where is going to be the new location of a nuclear power plant or the airport, you have to make dozens of or hundreds of elementary criteria. You have to evaluate them separately and then aggregate them logically. That means taking into account degrees of simultaneity, degrees of substitutability, and importance, and put it all together. And wherever you come to decision is a single scalar value. And this is interpreted degree of satisfaction of our requirements. We had these requirements, and the overall degree of satisfaction of our requirements is the final result. It can be interpreted as fuzzy membership in the set of ideal systems.